We do have some improvements I've made to this one. So number one, when the input voltage is within the operating range, set the current time based on the selected time. So this is going along with the idea that there are going to be some conditions where we actually do allow user inputs. And then maybe we also are going to allow the user to do the selected time input, and maybe we're going to allow them to change the volume. So the idea here is I want to show that you should be specifying the requirements that actually happen. And like we said, we could use state machines or some other things as well, maybe instead of repeating these conditions. But the idea is don't write a requirement about what's not going on. Make sure you've clarified when you're doing something with conditions and then say what you're actually doing. There's a note here, obviously, to fully improve this requirement, we would need to specify all the system functionality and the conditions under which it's available. So this is not meant to be complete. It's just an example of let's turn the do nothing requirement into what are we actually doing and when are we actually doing it. Comment from Brad, the level of abstraction, if the element that disables or precludes the function, like a software element perhaps, is below the system level, then this requirement properly formatted might be at a lower level in the hierarchy. This is a very, very good point, and it's one that I see all the time. The argument that I usually see about things like this is, well, we have to do this because if we don't do this, the system won't work correctly. The danger that can happen is then you're building in, again, because it's a software feature maybe that will disable this, you're building in the software feature implementation up at your system level. And now maybe you've done something that you can't undo later if that's not the right thing you wanted to do. So 100% agree with the comment about abstraction. You need to make sure, again, always going back to that system boundary, what do I know at this level? What can I verify or design at this level? And then the lower level requirements should hopefully add up to meet that need. So whatever software requirements you have, maybe ones that disable the features in a certain state, they should be tracing up to these requirements that say, in this state, I have these features available, or I disable these features. So yes, there's a characteristic about appropriate to the level as well that Lou pointed out. Requirement 4, I like this one. So system shall be portable and waterproof. Okay, so this I tagged under measurable performance. I also probably could have tagged it under vague terms. But here, because I think the intent is that there's some capability here that the stakeholder is expecting when they write this requirement. But how can we quantify this? So what does portable mean? What does waterproof mean? If a requirement is written clearly, all the users should be able to interpret it the same way. If they can't, we need to revise and get to that common understanding. So in this requirement, portable and waterproof can mean so many different things across the board. There's no common understanding whatsoever. Let's go to the next one. Single thought sentence. So in this case, we're not specifying an action necessarily for the system so much as maybe a characteristic, but there's two different ones specified here. So the verification I need to do to ensure my system is portable might be very different than the verification I need to do to ensure it's waterproof. So these are two different characteristics per Rule 18, single thought sentence. They really should be split into multiple requirements. So here, again, some improvements. There's many different ways to solve this, but this is how I chose to solve this. So the system shall measure less than or equal to, I gave some dimensions. So that's one way that you could quantify this portable need. Whoever said the system needs to be portable had something in mind. So those discussions, to go back with them and clarify, what do you consider portable? Maybe it's certain dimensions, or this next requirement, system shall weigh less than or equal to 1 pound. Maybe these characteristics together actually quantify that need of portability, but in a way that we can design against it. For the one about waterproof, maybe it would be better to specify an ingress protection rating. So I looked up ingress protection and chose something that basically means the system should be able to be submerged in water without damage for X amount of time, and I think it's dustproof. That characteristic is a valid need, but there has to be a way that we can quantify it so we can design a system against it. No system can ever be anything proof. Some comments here. So I've seen vague terms, portable, waterproof, defining a requirement as commentary. It's not part of the shall statement, but it's part of the requirement object text. Is this frowned upon? I think we're going to get to this one in another example soon. Yeah, and I like your other comment from other Theodore. IP75 is definitely going to break the cost requirement later on. Yes, we will get to that. In terms of extra stuff in the requirements, I'm very against it. Maybe we'll get to that as we come into one of the next examples, though. There's a rule broken about purpose phrases or additional explanations. Let's get to that next slide because I think I have a better explanation there. Findings for requirement 6. I purposely skipped requirement 5, you might have noticed. We're going to get to that in a minute when we talk about the set of requirements. So don't worry, I didn't forget about it. And just to remind you, requirement 5 was about the system can't cause a fire if it gets damaged by water. There's a reason I'm skipping it right now. So requirement 6, systems shall have an alarm feature so that the user can wake up on time and the user must be able to change the volume of the alarm, etc. Lots of broken rules here. Number 1, purpose phrases. So you don't need to say in the requirement why you need to do the requirement. Typically, there might be a trace that you could do back to a stakeholder need or something else. So if a stakeholder says, okay, I want an alarm so the user wakes up on time, great, they can say that, that's fine. When we write our requirement, we can trace, system shall have an alarm or whatever the requirement is back to that need that we want to make sure they can wake up on time. You don't need to include the purpose statement in the requirement itself. Superfluous infinitives. This is fun because this came up a lot in the crowdsourced examples. So don't say phrases like be able to or allow. You want to make sure your system is doing the thing it's supposed to do all the times it's supposed to be doing it. So if I'm able to do something, say I'm able to do a pull-up one time, that doesn't mean I can always do a pull-up on demand. So it's not a good way to write your requirements. You want to write them more directly. What are you actually doing? Parentheses. So avoid parentheses. In this case, it's kind of a mix of, I actually have another requirement happening here. I didn't point this one out because we already talked about single thought sentence, so I only pointed it out in the fix. But parentheses can usually be an indication either of we're trying to put more information into the same requirement, explanations, purpose phrases, things like that, or we actually have another requirement we're trying to slip into that same one. I think all of those situations I would say are bad. You want to ensure the wording of the requirement is clear. If you're putting multiple requirements in, split them out into different thoughts. If you do have supporting explanations and things, it's not that those are bad, but I would typically put those into separate information statements. When you're writing your requirements, I imagine they're in some kind of document structure. You can have additional explanations, diagrams somewhere else. That's actually also a rule. I didn't specifically call it out because we didn't do it, but this rule here, Rule 23, for a supporting diagram model or ICD. So if there's something going on and you think the requirement is going to be supported by having additional information, you can do that. But you don't need to add that explanation as an aside note in your requirement itself. You don't necessarily want to clutter up your requirement with all this additional words coming out of, thoughts. You don't want your requirement to get cluttered up with random thoughts. You want it to be very clear. Open-ended clauses. So don't use something like etc. because what on earth does that really mean? Clarify the scope of the requirement and make sure it's clearly stated in a single thought. If it's something that you need to do, make sure that's actually listed out. We can't interpret what etc. means. Different users might have different ideas. We're going to go on to requirement 7, and then we're going to talk about the set, and then we're going to go to our crowdsourced examples. Requirement 7, systems shall cost less than $1 if possible. Take my money. So first of all, this breaks the actual characteristic of a requirement. So I switched it up a little bit here. Feasible is a characteristic. So $1 sounds pretty good if this system is waterproof and it's portable and it's able to report time in multiple formats and things like that. And I can have an alarm. Sounds pretty good. However, it's not really realistic. So here, you'd want to make sure as you're looking at the requirements, you're analyzing the costs, the capabilities, and the needs, and you're kind of comparing all that information to each other. Based on the stakeholder priorities, if they have a need for more of this functionality or these capabilities that they've specified, we may have to ask for more money to build it. If the cost is the highest factor, maybe you have to cut out some capabilities and you have to truly understand what they really need, what's the most important to them. So this idea of prioritization of the requirements and getting clarification of the needs, it really can help make sure that you don't end up with a system that's wonderful, but costs a lot of money, or that's really cheap, but doesn't actually do what the customer wanted. Next, escape clauses. This is a great one. I think this also showed up high on the ranking list of the user submitted requirements. Sadly, there's no A for effort. If we try our best, if we try really hard to make this wonderful system that reports time cost only $1 and it ends up costing $1,000, that's not okay. We didn't meet the target that was set for us. So it's actually better to understand, as we mentioned, better understand the needs and the capabilities and go back and have those tough discussions where needed to ensure that you can actually build something. Don't use these get out of jail free or escape clauses like if possible or when needed or things like that. A comment from Lou, is the cost requirement really a requirement on the system or on the organization developing the product? A lot of cost considerations are addressed in the design decisions. I say this because the issue of feasibility should have been addressed before the needs and requirements are defined. That's a good point. I often do see cost or maybe materials selection somewhere in requirements that's coming from customers, but it might be, like you said, more of a need, and we have to comply with it, obviously, but how does it translate into actual requirements? So cost may be a goal or objective assigned to the project team as part of a business or marketing requirement. Should these types of requirements really apply to organizations be included in the requirement set of the system? That's a very good question. I think process requirements fall into that same category. So sometimes requirements about you have to comply with certain quality standards. Maybe you have to have a person in charge of functional safety in your organization. That's a requirement I've seen. It's not really a system requirement, it's more a requirement on the process. Do any users have good advice for how to group requirements like that they're not necessarily system specific, but they're still coming in from your stakeholders as a need? So there's some more discussion back and forth about the cost. So some users think it is a requirement of the system because the cost constraint might be meaningful until the needs and the requirements are drafted, and you want to make sure the cost target matches the feature scope. Some other users say, Theodore says, from previous experience, cost is a requirement derived from budget, but not typically flowed to an engineering level. The SMEs are definitely not in agreement on this one. I think this is still about cost. So interesting, there's a lot of discussion here about cost and whether that is something that we should specify as a requirement or if it's more of a marketing thing or a product need. Very interesting. So business development team often includes cost as part of the client's requirements. So oftentimes it's not possible to build a system with whatever cost they've specified. So either you can meet the cost and miss some of the requirements, or you don't miss the cost, you meet the cost, but you can't do all the requirements. The usual practice for this is feedback and let the business development team decide which are the cardinal requirements. So yeah, I think like we've mentioned, being able to go back and clarify the priorities with the business team or with the customer, if you're able to do that, in the end, something's got to give. You got to compromise something. I see another comment from Brad that thankfully we won't have to verify this one since it's not possible and cost isn't the same as price. Yes, good point. When I said cost here, I think I was referring to how much it should cost to build it. I see one more comment from Frank. Is it normal to include cost as a requirement? I've only ever seen it in contracts outside FPS. They're not exactly a requirement on your system or on your product so much as they might be a requirement on your development process or maybe your quality processes or your organization. Because a lot of the times in standards, we will find requirements like this. And so the question is, what do you do with them? Do you still have to meet them? These requirements should be treated as requirements, but often they should be grouped separately from the system or the product requirements because the way you're going to be verifying them is not actually part of the system verification itself. So the next thing I have is the set of requirements as a whole. There's a couple of findings you may have been thinking about that we didn't cover as we were going through the individual requirements. So number one, complete. I'm sure that the requirements that I proposed, as terrible as it was, it's even more terribler, because it's missing stuff. We have no idea about how this system is powered. We didn't receive much information about that at all. Is it a battery? Is it hard plugged into the wall? Is it solar powered? We don't know. And so obviously those requirements need to be written because our design can't do something when we haven't clarified what needs to happen. How do you set the time? Is it manual? Like, do you have to turn a dial to set the time? Is it digital? You can put in a number. Is it you press a button and the time increments? There's so many ways we could do this. We never said that you have to be able to turn off this alarm. So theoretically, there's an alarm. The user can set the alarm. They can change the volume, but can they ever turn it off? I hope so. Otherwise, we're going to have a lot of product recalls. Lou had a good comment here that missing a requirement concerning the readability of the display. So should have a standard governing the characteristics of what is being displayed, the font, color, the size. Exactly. There's a lot of things we did not include in this requirement set, and it becomes more obvious as you're looking at the boundary of the system and also understanding maybe the use cases for the system. Who's going to be using this clock or alarm device? Making sure that as we write the requirements, we have a good understanding of the problem first, and that we check at the end, do we cover everything, can be really important. Consistency. So this is why I did not specifically talk about requirement 6 in the individual requirement findings. Sorry, I think it was requirements 4 and 5 actually. Requirements 4 and 5 contradict each other. So if you remember requirement 4, so systems shall be portable and waterproof. Requirement 5 said don't cause a fire if there's water damage. How can those two requirements coexist at the same time? If it's waterproof, then we should never have water damage, right? So just another example of how you need to think of the requirements as a set as well as individually and make sure that they make sense. And then feasible. As we mentioned, it's really sad that we won't be able to make this wonderful, amazing system for $1 because we have so many things we're trying to do. So the cost is not really realistic. Maybe that's what the stakeholder specifies, but again, if we can't do it, we can't do it. You need to find where the compromises can be made, either in the technical capabilities of the system, in the quality characteristics of the system, or maybe in the cost. If we can't meet everything, we need to analyze and prioritize and come up with a solution that gives us the best way of achieving the stakeholder needs within the context of the boundaries that we have. Nice comment from Theodore. So about the battery technologies and certain ones that are made with alkali metals, they can actually ignite or explode when exposed to water. So it's funny because it seems like the risk of fire from water is not as far-fetched. Nice example there. I think that's why making sure your requirements are quantifiable is even more important, because if you need it to be waterproof to avoid a fire, you better make sure you've designed it waterproof enough in a quantifiable way that you can test it and prove that it's not going to have a fire. From Douglas, requirements 4 and 5 are not quite contradictory. Waterproofing may fail, in which case the system must not catch fire. I think I understand your point on this one. For me, what would be better is in the requirement 5 that was too vague. What does waterproof mean? We need to actually clarify what level of water protection is required. Obviously, it's not going to be fully waterproof. And so then we would have other requirements. After we've met this requirement about how waterproof it must be, what does the system need to do in that gap that happens afterwards? Next, because there were so many great examples submitted by the teams, I wanted a way to better show what's going on. We don't necessarily have time to read through maybe 30 or 40 examples, but what this is a word cloud. The way it works is the more times one of these rules was broken in the examples that were submitted by the team, the larger the text shows up for that particular requirements rule. Looking at this, and this is nice because it gives us a way to take a lot of data in a qualitative way, understand what's going on with it. So for example, active voice actually turned out to be one of the biggest problems that we saw in the submitted requirements. This meant that a lot of the requirements you guys have seen that are terrible say something like shall be, or shall do something in a passive voice. And we can jump to the examples to go through in a little more, but the next one, unsurprisingly to me, was vague terms. A lot of requirements that we see are going to say something like maximum or quickly, or basically if you see an adjective or an adverb in your requirement, chances are there's a vague term happening. Those vague terms need to be quantified into something that we can actually verify against. And quickly, super subjective. It could be very different depending on if you are measuring something in milliseconds from your perspective, or quickly might be years if you're measuring maybe climate shift or something like that. Next thing that was really high on the list was the superfluous infinitives. So this is the one that says shall allow or be able to, or those ones that you're adding some extra wording that takes away from the fact that your system really needs to do something under the conditions that you specify it. So those extra words don't really help, and they're kind of a cop out. So if you're able to do something once under those conditions, but then 99 out of 100 times you can't, you really didn't meet the intent of the requirement. So other ones that kind of stood out among what we saw, using measurable performance. So again, specifying actual values instead of random statements. This kind of goes hand in hand a little bit with the vague terms. And then single thought sentence, putting multiple requirements together, using escape clauses like if possible or when required by the user, or all of those things are bad. Some of the ones that were not as prevalent, but it's interesting that they did show up. So there's 42 requirements rules in the INCOSE guide. We don't have 42 rules shown here. So it seems like there definitely are some rules that people are homing in on as being more troublesome or more prevalent. So things like abbreviations and acronyms we talked about. It's okay to have acronyms, but you have to make sure they're defined somewhere. Abbreviations should most likely be avoided. Use an acronym that's defined or spell out the term. Having structured sets of requirements can help. Avoid escape clauses and open-ended clauses and absolutes, all of those things that you're not really going to be able to prove that you did it, or that you're going to say, well, I tried, but it said if possible, so I still met the requirement. None of that really works. Let's see, I see a few comments in here that we'll talk about briefly before we go look at the examples. So comment from Pedro, I work on automotive industry, and after DevOps be introduced on our software development, we were pushed to leverage requirements, quality, and system verification validation. One of the best solutions seen so far is to use behavior-driven development scenarios like Gherkin through executable specs, because it becomes easy to integrate with automated tests. The requirements use given, when, then structure to develop requirements for both development and testing. How do you see that from INCOSE and systems engineering point of view? And I think, Lou, you might have given a reply to this. I'll read it aloud. As an organization, you should define your own templates to match your processes. So the Guide for Writing Requirements has several rules that state organizations need to define their own standards or tailor what is in the Guide to Writing Requirements to meet their needs. So this is the list of all the requirements that were submitted by everyone who came to these meetings. You can maybe give some feedback. Do you think that I've categorized the rules correctly that have been broken, or are there additional rules you think we broke? And also, what do you feel about this other slide? Do you feel these are the issues that we see most often, or do you feel there's other requirements issues that come up? So I'm gonna jump over to this slide so people can have a chance to look at it. And I'm going to read through some of the feedback that's popped up during the last couple of minutes while we've been on this slide. There's a comment on this slide, drawings of the system shall be provided by CDR. So this one says a standalone task to provide drawings before a critical design review rather than a requirement. Because we violated the rule here about active voice, when it's passive voice, you don't necessarily know who the requirement is for. And in this case, it almost sounds like it's more of a development requirement. So if CDR means critical design review and you have to provide system drawings before then, this is like a business organization requirement that you're going to have to show to the customer. Still valid that they can ask for this, but it's not really a system requirement. So where would you put this? In my experience, requirements like these are tricky because they tend to get deprioritized in favor of writing the system requirements. It'd be interesting to see how other groups handle this when you have requirements that are not for the system design itself, but around the development process or business practices or things like that.
We got to be careful of requirements on people, process, and products, and they shouldn't be mixed. So we have a rule that you didn't mention, and it talks about the noun-verb agreement.
Yes.
So look at the noun, but if the verb doesn't apply to the noun entity is not going to be able to perform the action implied by the verb, then you have an issue there.
Definitely. Some comments here. The drawing requirement could be in a statement of work. So, right, something that the organization has to do. We actually do have to meet this, but it's not going to be included in with the system requirements. Comment from Monica. In my recent company, we were calling the third CS requirement as a boundary condition, not on the system itself, but something to be considered. So maybe that's kind of similar to what Lou mentioned about like a statement of work. So you do need to meet it somehow, but it's not part of the system. Lou has a good comment here. There should never be any user shall system requirements. Fully agree with that. Again, it's not in our control. We can't guarantee the user shall do anything we want it to do. We can design a product or a system and we can make sure that it meets a need, but what happens to it after that, we can't control what the user does as much as we might like to. Let's go to one of the next examples and see how people feel about these. In this first one, they're specifying that we have to use a certain data bus by a certain manufacturer. I did include a rule here that's broken in the solution-free rule. However, sometimes we may have things like this that it's a mandatory, you have to do this from a customer or a stakeholder. They might tell you you have to use this certain component because we like the supplier and we have good experience with them and you better make it work and we're buying your system. And they can do that. So the trick here is know when you're specifying a solution that doesn't need to be there versus one that is a mandatory need. So if you can't trace a solution-based requirement like this to a need, you should question why you have it. The next one, so accuracy of the temperature difference is not yet or not more guaranteed, pretty open-ended. We don't really know how to quantify this requirement. The next one is about those superfluous infinitives again, shall allow for, shall handle. Again, it's not clear enough. Let's just say what the system is actually doing under a specified set of conditions. This next one about user need, non-inferior performance compared to closest competitive options. Honestly, this one just feels like a cop-out. It's basically saying, design a good system that's better than everybody else's and go for it. It's not clear enough at all, and it's very, very subjective. We need to know how the competitor designs their system to meet this. We could do other things to measure this. Maybe we want a battery life that's longer than our competitor and we know what their battery life is. Okay, then maybe we go target a better one using some newer technology. But as written, we can't really do anything with that requirement. The next one is about requirements that are written as a run-on sentence or short story that can be difficult to interpret and verify. This goes back to that rule about a single thought sentence. So yes, if there's way too many things happening in the requirement, if you needed to stop and reread it a couple times, chances are you've got too much going on and you need to reframe into multiple separate requirements, one for each thought. And then ones that are not specific, I categorize that under measurable performance. We should have a way to quantify what's going on with the system. One thing I'd like to see as we're going through this, so keeping in mind that word cloud and the issues that were highlighted the most, do we agree with that or are there other issues we see most often? So keep in mind the big ones were the active voice, the vague terms, the measurable performance, escape clauses and open-ended clauses were kind of in there. The superfluous infinitives were there a lot. So some of these ones too that were more of a statement than a requirement, like just showing what's a bad thing, these I kind of categorize as I best thought. So if a requirement has too much information in it, it could violate the single thought. If they're not specific, it could violate measurable performance. There's a question from Lou about when specifying accuracy, should precision also be stated? Maybe I'll open that one up to the team, see what people think. Keep going through some more of these examples just so we can see all the ones that people submitted. I like this one at the top. Whatever product shall be serviceable with standard tools. This is a great one because, again, what on earth are standard tools? If you are an aircraft mechanic, your standard tools are going to be way different than if you have a child's play tool set. It's not going to be the same thing you're working with. Or if you're a chef, your tools are not going to be the same. Let's see. I also like this one here. The weather shall not affect the component's function. Wouldn't that be nice? Using not in the requirement here is not a good idea. And we have an opportunity to write the requirement better if we use explicit conditions. Like maybe we would specify certain conditions when the system has to perform certain activities. And then if it's outside those conditions, maybe we would specify a degraded performance or something. But it's very unrealistic to expect that any weather condition, such as at the bottom of the ocean or in Antarctica, is not going to affect your system's performance. Lou had a really great point there's a mix of sometimes needs and requirements getting intertwined. And I think you feel free to expand on that, but it seems like needs can be said in whatever way they need to be said. Sometimes just plain language is enough, like make it cheap. That could be a need, but you can't make that as a requirement also. You have to do some interpretation of that from need to turn it into a requirement, right?
One thing that we did in the latest version of the Guide to Writing Requirements is we say the rules and characteristics apply to both needs and requirements. But if you look at Appendix D, it goes through and say which rules apply to both, which rules apply only to the requirements and not so much to the needs. So there's a different way we apply the rules depending whether it's a need or a requirement. But still, the needs have to be understood. If they're totally ambiguous, then how do we transform them into a set of requirements that will result in a system that meets those needs? There's got to be some discipline in how we write the needs as well.
Right. That's a great point. And I think the way I've seen it play out is typically there'll be those first meetings you have with your stakeholder and they're asking for some things and something is not clear and you're going to discuss about it and clarify. Usually the questions that we like to ask here, what problem are you trying to solve? Next, requirements that encompass everything. Needs to fulfill this, but not limited to. Again, it's just more of those open-ended clauses. We can't verify stuff that we don't know. We can't design stuff that we don't know. So the requirement has to be clearly bounded so that we can do something with it. This next one about system performance shall not exceed, and then there's some units and things here. The use of not, again, we should try to make sure that we can write this in a way that's verifiable and bounded. The abbreviations in here, to be honest, threw me off. So this is one example where I would say having abbreviations, unless everybody clearly understands what's meant, is not a good idea. We'll put it in your data dictionary. And on the bottom one, the detector's probability of detection will be 100%. This is active voice, and it's also using a absolute term. So we can never hope to have a system with 100% accuracy unless you want to fail all your verification testing and make your test team really unhappy. 100% anything, most likely. So how are we going to meet this requirement? The probability of detection, is this done by this detector or is it done by some other system? We need to make that clear. And there was a question from Gaston about what does performance mean here? Right. I think they were probably using it as just a generic placeholder, but to show that this requirement is not very clearly written with whatever these numbers mean. Yeah, and this last one, they did not include a shall. So again, for most of us who are used to writing requirements, not seeing a shall is going to instantly trip us up and we're going to wonder if it's a requirement or if it's really just information. I'd say for anybody in the requirements management space, having that consistency within your organization is really important because it will confuse your users if you flip-flop or if you're not consistent about using shall as a mandatory statement. Okay, so comment from Monica. By the way, in context of complex statements and stories, when I mentioned if then else earlier, it may have been more of an aid to understand the requirements separately and confirming with the stakeholder. Then use this to split up the statement or paragraph into separate requirements. Yeah, that sounds valid. I think techniques to break down a confusing requirement and understand it so that you can write it in a better format is definitely useful. And then from Jim, FAA lawyers have struck shall from all requirements from the agency. That's interesting comment, Jim. Do you have more information about why they've done that? Lou says we had an extensive discussion on this in Viva Engage. So also a great place to ask questions like this. I know I've personally done that too. Just something feels weird or here's a situation. How do I handle it? It's a great place to get a lot of good advice from team members like this. I see a comment from Lou, one that says the system shall perform better than our competitors 2 years from now. Right. Do we have a crystal ball? Do we have corporate espionage going on with our competitors? Like, how could we possibly verify a requirement like this? How could we use a requirement like that to design our system? Let's see, we've got a few more here. I think we have another one here. Consumer appliance shall require PPAP. This is another one. It's not really a requirement on the system. It's more on the development process. So still need to think about this somewhere, but maybe we wouldn't group it with the system requirements. I like this next one. The rail cars shall be aesthetically pleasing. That could mean many different things to many different people. This next one. So we have kind of another one of these. Passive voice shall be designed. And then there's some process that's mentioned. There's a lot of stuff going on here. There could probably be some more rules broken on this one, but not necessarily clear unless this process XYZ has been clearly defined somewhere else.
One thing that I really like and I used as the basis for a lot of what in our products is the medical device industry. And they have called a quality management system. And as part of that, they have design controls. And the design controls are requirements on the developing organization to follow those rules. And so that one, it needs to be written better, but it would be included in the design controls because it's not in the system. It's on the organization producing the system.
Sorry, Lou, this is Brian McCormick. I actually work in that industry. It's a brilliant point. It's exactly how a lot of the SOPs, a lot of the development structures are on the organization as a whole. It's not actually on the product itself. I have experience of trying to get rid of these requirements, which is why it jumps out a little bit at me from the system side.
Good discussion. I think we have one more slide of some of these ones, just so everybody gets a chance to see their requirement up in light, their bad requirement. I think we've seen a couple of variations of this one now. Shall be as robust as possible, shall be 100% accurate. We know that these are bad. There's some escape clauses going on. And again, active voice seemed to show up a lot in the bad requirements. I think there's something to take away from that. Yeah, this one is interesting. Workstation 1 shall be able to control something with limited capacity if the situation deems it necessary. So workstation 1, I'm curious if this is a person, if this is a system, if this is some AI, because the way it's written, how can we actually make sure that workstation 1 is capable of doing this? Or is it more like a process control that how workstation 1 is used by the person who's operating there can make sure this requirement happens? Definitely the passive voice seems to lead to a lot of confusion about who's doing this and is it even valid for my system? This one, listing titles. Actually, I'd like to ask this question to the team maybe because this does come up a lot. I think I've seen it in the Viva Engage chat. Referring to a standard or to a code of federal regulations or something sounds like it's a bad practice, but what's a better way to handle it when you have something like that?
So as a need, I think it's okay. If you go to both our INET page as well as the YouTube channel, there's a whole presentation that I did on compliance with standards and regulations that goes into a lot of detail on that. But the quick answer is, if there's a need to comply to it, that means that the project team needs to look at the standard regulations, see which ones actually apply to the product, and then derive well-formed requirements that meet the intent of those requirements. The problem with a lot of the standard regulations, they're really requirements on the organization, not the product itself. So one thing we got to do is make sure that we don't just blanket call out something like that and just kick it down the road and let the design team figure out which ones are done. Because from a verification standpoint, do I really need to have proof that I've met every single requirement in the standard regulation? If I'm not specific, how do I even handle verification?
Thank you. That's a good answer. From my experience in automotive industry, this comes up all the time because there's many standards. I could just think of a few like cybersecurity, functional safety, UDS. There's many, many standards out there where the intent of what we want to do is say we comply with that standard. But then again, like there's thousands of requirements in those standards and a mix, as you mentioned, Lou, of maybe process or development requirements versus actual product requirements. And I think teams struggle to differentiate between how to handle those.
I can just add to that. So I think if you want to go by the book, you should read through the standard, understand exactly what the expectations are, considering your kind of variant of product and what is the subset of things we're really going to make sure we comply to. But I think reality can kind of hit you sometimes as well, and especially when you have, not talking about my industry, that there can be like construction clauses with a ton of expectations on the design itself, and it can be almost unpractical to extract some of those things sometimes. So I think even a hybrid approach where maybe some clauses of the standards you can pull out and write as really well written requirements, while some are more like, that's going to be like copy pages and pages and pages. So maybe for this particular clause of the standard, it makes more sense to just say, okay, follow this clause.
There might also be in some standards, there's options on how compliance is achieved. So for consistency across the project team as to which option is being done, sometimes it's better to list out the individual items just to clarify that.
Yeah.
And we're taking option A rather than option B.
Yeah. The famous systems engineering answer, it depends.
I know. I feel like I should say something because I work for SAE International and we write and publish a lot of standards you have to follow. And that's something that we've actually been looking at even in how we write our standards, making it more clear when requirements are, which statements are requirements and which ones are not. Because I think as people look to see, are they meeting a standard or not? I think we're going to have to think of standards almost as, in many cases, like a list of requirements that you need to pull in so that you can ensure you're meeting those requirements along with any other source of requirements that you're meeting. So I know that's something that's been on our mind quite a lot as we look to provide standards in formats that will make it easier to work with the systems you guys are using.
That's a great comment. Thank you, Leslie.
I think I see it as a need to comply to the standard, and you can get a certificate showing that, the regulator or some accredited body actually confirm that you comply to this regulation as a whole. But I see that more as in the need space. But again, you need to understand what the actual expectations are. And I think that there are probably a lot of situations where design teams, they maybe design based on, this is how we used to do stuff, but they don't know exactly what the standards are saying. So because it's so complicated to digest that information.
Well, that's a good point too, because unfortunately, the requirements and standards are poorly written. They violate a lot of these characteristics and stuff. And so you almost have to guess what the real intent is. So if the standards make it clear that this is a requirement on the system, this is a requirement on the organization developing the system, this is a requirement on how you're going to do certification, qualification, verification, put them in separate sections. I realize that standards are written on a generic class of products and not on a specific product. So there's got to be some ambiguity in how they're worded. And that's why each project needs to go and say, what's the real intent? We didn't talk about it in this presentation, but we have a set of attributes can be defined for a requirement. And the key one is rationale. And so if the standards organizations could actually include rationale for each requirement, then us poor implementers would actually kind of understand better the intent. I don't know if you want to comment on that, Leslie.
I agree. I found many instances where requirements are poorly written in standards. And I've even gone back to some of the committees where they say that they have intentionally made things vague. And for whatever reason, it's not right. But I've been looking at that quite a bit lately because as we look to provide standards in a more digital format, requirements from standards could be taken out of the context of the PDF and be included in requirements tracking systems or SysML models and such. And I feel that and it's going to be a big change, for a lot of standards authors, but I feel that we really need to be thinking about visual requirements within standards, having them be more discrete, having them be more standalone, having them be more understanding that someone might not have the context of the entire document. I feel that a lot of standard authors feel a certain sense of security or feel that they can rely on how you have to read the entire PDF. But what's the reality? How many people are reading the entire PDF? When you're meeting a standard, you're trying to figure out exactly what from that PDF that you need to prove compliance to in some way. And I think that it's been a major point of discussion here at SAE as we look to change how we're writing standards. And I've been trying to push a lot of things that people have taken for granted. Even something as simple as a blank cell in a table. What does that mean? If it's part of a requirement, how should that blank cell be interpreted? Is it zero? Is it not applicable? Is it not tested? Is it null? Is it, there's like 20 different definitions. So I do feel that there's still a lot of ambiguity in how requirements are documented in standards, and we're going to have to change that. I think as more companies look to really build out these digital threads and digital twins, standards are going to be a big part of that. And they can't continue going on being as ambiguous in some cases as they are today.
It looks like we're just about at time. I don't have anything more to present. I think we can close out for today.
Thank you very much for another good presentation.
Thank you, everybody, for the comments and for the feedback in advance, too. That was really helpful. I think it makes the presentation much stronger to have that input.
Certainly. Thank you, Sarah. It was a great presentation.